friends, this is Kruti Jaipancholi, Assistant Professor in LG Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Fiber Optic Communication. So friends, till now you have studied about the various waveguiding structure, about the optical fiber, okay. So now from this video you will learn about the signal degradation in the optical fiber. So now we have also studied about the manufacturing, the fabrication process of the fiber. Now the question over here, that is, what is the material absorption? The absorption by the atomic defects and the extrinsic absorption. So that we need to study from this video. So friends, what is the absorption? The absorption loss is related to the material composition and the fabrication process of the fiber. The absorption loss that also results in the dissipation of the optical power as near in the fiber cable. So, the material composition and the fabrication process, what kind of the loss can be present? As we have earlier studied, it's a absorption loss. So, it is always related to the material. And due to this loss, there is a dissipation of the power in the fiber optic cable that can be present. The glass fibers that are the extremely pure, as we have studied. So sometimes the impurities still remain as residue after the purification. So that also results in the absorption. So amount of the absorption by these impurities, that depends on the concentration and the light wavelength. So, what could be the wavelength of the light that on the absorption value that can be achieved? So, according to all this, the material diffraction, the absorption that can be occurred, this absorption by the atomic defect in the glass composition, the extrinsic absorption by the impurity atoms in the glass mats, and the intrinsic absorption by basic constituent atom of the fiber. So these three are the main causes of the absorption. We need to study this all absorption one by one. So one is the absorption by the atomic defects in the glass deposition. Okay. So what is about the atomic defects? So there are the imperfections in the atomic structure of the fiber material. What kind of the atomic defect? There is a missing molecules, the high density cluster of the atom group, then the negligible, okay, the absorption loss is there if such kind of the atomic structure defect is less. So this absorption losses, they are negligible compared with the intrinsic and the extrinsic losses. Okay, so now the absorption loss effect or the absorption effect is most significant when fiber is exposed to ionizing the radiation in the nuclear reactor, in the various the medical therapies and the space missions. So this atomic defects that gives the result in the various particular field. Also, the radiation dents the internal structure of the fiber. So the damages are proportional to the intensity of the ionizing particles. So the radiation over the internal structure of the fiber, this damages are proportional to the intensity of the ionizing particles. This also results in the increasing attenuation due to atomic defects and absorbing optical energy. The total dose a material receives is expressed in the radian, and that is the unit of measuring the radiation absorbed in the bulk silicon. And for that it is the 1 radian SI is equal to 0.01 joule kilogram. Now, the higher the radiation intensity, more the attenuation. As you can see in this diagram, it is of the ionizing radiation intensity versus the fiber attenuation. So you can see over here that the radiation intensity that is increases, okay, the amount of the attenuation that can be also increases. So now the next thing that is about what is the extrinsic absorption. So the extrinsic absorption that is due to the transition of the ion from the one energy level to the another energy level. So it occurs due to the electronic transition between the energy level and because of the charge transition from the one ion to the another ion. Now this could be the major source of attenuation. So from the transition of the metal impurity ion such as the iron, chromium, cobalt and the copper. This losses value that can be up to the 1 to 10 dB per kilometer. And the effect of the metal impurities that can be reduced by the glass refining technique. So this is about the extrinsic extrinsic emission, okay, absorption. The extrinsic loss that can be also caused by the absorption due to the hydroxyl ion impurity dissolved in the glass. So vibrations occur at the wavelength between the 2.7 and 4.2 micrometer. So the absorption that peaks at the wavelength around the 1400950 and the 750 nanometer. So these are the first, second and the third overtones respectively. You can see into the particular figure. Okay. So here you can see the diagram in which the absorption spectra for the hydroxyl ion that shows. Okay. And between this absorption peaks there are the region of the low attenuation also. So this way the extrinsic absorptions that results. The last point in this kind of the absorption, that is the intrinsic absorption. So now the question is, what is the intrinsic absorption? So intrinsic absorptions that occurs when the material it is in the absolutely pure state. No density variation and the inhomogeneities are there. The intrinsic absorption that sets the fundamental lower limit on the absorption for any particular material. Also, it results from the electronic absorption band in the UV region and from atomic vibration band in the near infrared region. Over here in the intrinsic absorption, the electronic absorption bands are associated with the band gap of amorphous glass materials. Okay, and this occurs when a photon interact with an electron in a valence band and excites to a higher energy level. UV absorption decays exponentially with increasing the wavelength. Okay, so intrinsic absorption in which we can find out this. Also, if you go into the IR region, so in the IR region about the 1.2 micrometer, the optical waveguide loss that is determined by the presence of the OH ions and inherent IR absorption of the constituent materials. Okay, so IR region, UV region, intrinsic absorption for the particular wavelength we can found. So in the inherent IR absorption, that is due to the interaction between the vibrating band and the electromagnetic field of optical signal. Now, which will result in the transfer of energy from the field to the band. So that is why it rises into the absorption. And this absorption, that is very strong because of the number of bonds they are present in the fiber. So now the attenuation spectra for the intrinsic loss mechanism in the pure GE is shown in the figure. So here in the diagram you can see that the attenuation spectra, okay, for the GE value, the pure GE wave value. So what could be the wavelength value? Okay, everything we can see it from this particular diagram. So the ultraviolet loss at any wavelength is expressed by the alpha UV is equal to 154.2 upon 46.6 x plus 60 multiplied by 10 raised to minus 2 e raised to 4.63 upon the lambda, where x is the mole fraction of GeO2 and the lambda is operating wavelength. Alpha UV, that is the attenuation in dB per kilometer. So this is regarding the extrinsic, intrinsic and the atom absorption due to the atomic defect and the material, the dispersion. Okay, so this way you can write the equation for the UV region as well as for the IR regions. Okay, and we can find it out what is the intrinsic absorption. So we have studied about the absorption. So in the next video we will study about more detail about the signal degradation in the optical fiber. So thank you very much everyone.